Hey guys, my name is Walter Jenkins. I'm a VDC coordinator with Rogers. I'm originally from Durham, North Carolina. I studied essentially 3D art through high school. Was thinking about going into the video game space. So I actually I applied to two different schools, NC State and UNC Charlotte. Ended up going to Charlotte, pursuing computer science. My path easily shifted, or I would say I hit a hard pivot and went into engineering. I actually thought I'd be building the next Bugatti and developing cars, but construction kind of just found me. I kind of been building houses with my dad ever since I was 5 years old. So just really thankful for Rogers. Coming out of school, I was with a soil tech company and found Rogers, shortly after, and it's been an amazing experience thus far. And I'll shoot it over to Virginia.
So I'm Virginia Sutton. I'm the virtual design and construction manager. And where my path kind of with construction started was at a very early age, building a lot of stuff with my dad, and then evolved into a whole lot of time that I spent with Habitat for Humanity in high school during the summers and on the weekends, helping build houses there. And so I moved into engineering when I went to college, actually. I studied structural engineering. And upon graduating, I shifted course to civil land development. So all the stuff that would be underground, I practiced that for 6 years before then coming over to Rogers in the virtual department to be able to do that for the past 8 years. And then Brian, if you want to go ahead.
Yeah, I'm Brian King. I'm actually an architect by trade. I went to school to be an architect. I was one of the few people that kind of knew in high school that I wanted to be an architect. I ended up graduating and practiced architecture for 7 years before I transitioned to the construction side in 2010. I felt that technology was kind of being pushed and driven a little bit more detailed on the construction side, and I felt like they were going to take it further places. And if you asked me what if I was going to be doing, 10 years ago, if I was going to be doing what I do now, I probably would have said no way. So I've enjoyed it. I've been an ACE mentor for 11 years now. The first school I mentored at was South Meck High School in Charlotte, which is where I graduated from. So ACE mentor was not at the school when I was there, but I have a passion for it because I would have loved to have been a part of ACE when I was in school. So that's a little bit about me. So with that, we're going to jump into the presentation. I'm going to tell you a little bit about our company first. So I like to say we are a small, big contractor. We compete with national companies, but we only do that in a regional area, which we are focused in the Carolinas. So we are headquartered in Charlotte. We do most of our work in North and South Carolina. We do touch Virginia and Georgia a little bit, but we are a women-owned company. Pat Rogers is our CEO. In 2020, we did about $750 million volume, and we currently have about 330 employees. So again, we're family-owned. We are still highly ranked, as you can see some of the stats here on a national level, but most of our expertise is in the Carolinas. So what we're talking about today, technology, and most importantly, how we use that technology for communication. So as you can see here, VDC, BIM, virtual reality, these are all tools that are utilized for us to communicate a process. And if we're not taking advantage of the technology to make a construction process better, then we're not using what it's for. So that's kind of how we got our title of our presentation in terms of coordinated communication, and that's what we're going to discuss. So we're going to focus first on kind of the pre-construction area, which is where we get involved very early in a project. Usually we're construction managers, so we like to be involved as early as we can so that we can help dictate cost, design, be involved, understand the project ins and outs way before construction actually starts. So one of the first things that is usually asked of us is, how much does a project cost? So again, in a traditional estimating way, we probably provide, Excel sheets and a lot of numbers, and that's great. But how can we use technology to make that process better? DeepProfiler is something that we invested in about 4 or 5 years ago. And what this software does is it takes all of our kind of historical cost database and it allows us to build it into a very simple model. So we can take a sketch that you would see kind of what you see on the screen here, this is a concept. So this is before we even start schematics. and we can construct a really simple, almost like a Google SketchUp type model. And as we build these boxes in these shapes, cost is automatically input to it. So what's really nice about this is then we can not only hand over a very detailed spreadsheet of what we think the project is going to cost, but we can also show the owner a picture of it. And the goal here is not to say, hey, this is exactly what this project's going to cost, down to the dollar. It's, do we decide to move forward? Are we in the right realm? Do you have a budget and a concept? Do they match up? So if the owner's budget is $20 million and we can get a sketch and all of a sudden we're at 40 million, it's time to pause. And it's great because we can pause early and not have to wait till we've spent months and months doing drawings before we realize we have a problem. Just a great tool that we utilize. We also do a lot of logistics, and we've, again, talking about Google SketchUp, free software. I think many of y'all have access to it. If you don't, please go download it and use it. But we started taking logistics plans and put them in Google SketchUp. And this is, a logistics plan tells you about the project and how we're going to build it. Where's our fencing? How are we bringing equipment into the site? Where's our cranes going to be? Where's our job trailer going to be? So again, using this really simple software, it's much higher level of communication than a typical 2D drawing. So we've started building these out and showing these really quick renderings to our clients, and this really helps them understand when that job site, starts construction, what it's going to look like. How is it going to be? How active is the site going to be? So just another great tool that we have to share information. Very complicated renovation for a hospital, and we had to shut down an ambulance entrance, which when you shut down an ambulance entrance for a hospital, it's a big deal. So the owner asked us to generate a video. So what you're seeing here is a video where we actually went through how we were going to build the project. We showed where fencing was going to be, how we were going to block off the road, where they were going to have to park ambulance. This was again, the whole purpose of this tool was to communicate information. So this little video took us probably about a week and a half to put together, and it was a tremendous value. They took this and they put it in the lobby of this cancer center, and doctors, patients, staff, everybody that could see this video play months before we actually got on the job site. So they knew what was coming. They knew how it was going to impact them when they came to the site, and it was just a really powerful tool that we utilized. Another huge part of the early execution plan and communication is schedule. What you're seeing on the screen is something we call the last planner system. You may have learned about it in ACE, but this is kind of looking at a schedule from the end and pulling it backwards. And unfortunately, before COVID, we did a lot of this where we would meet in a room and put sticky notes on a wall and really work through the sequences with our trade partners, how things were going to be constructed, how things were going to be detailed. But we've had to kind of find new technology now with the current state what we're in. So we've actually found software now, and this is something called TouchPlan, which kind of takes the sticky note concept of a schedule and puts it up in the cloud. It's pretty simple, but every color on here is represented by a different company, and you can kind of see the durations of a task that may take 15 days versus 2 days, but a nice little planning tool. And again, this is something that can be broadcast and sent to everybody so that everybody's on the same page in terms of schedule and progress.
So one of the projects that we have that's going right now is Pineville Bed Tower, which is in Pineville, North Carolina, just outside of the Charlotte city limits. It is a project owned by the Atrium Health hospital system here in the area. And so we wanted to highlight some of the stuff that we have done on that one. So you can see here a pretty picture of what it'll look like when it's done. So some of the information about it is it's about $130 million for the contract and a little over 250,000 square feet of new construction, and then about 27,000 square feet of renovation space in the existing hospital. And so that new construction, Tyler, I see a message, $130 million, I think is what you're asking for the contract. So it is about it is 8 floors tall, and there are going to be 108 new patient beds in the building. And so then the future build out that we plan for actually allows us to put an additional structural floor vertically above it in the future if we ever need to add that 9th floor. And then there's capacity to add an additional 108 beds in shell space on the upper half of the building. So Brian's going to talk a little bit about some processes that we started working through on this one.
So one of the things that, again, we were hired in this project about 2 weeks after the architect was hired. So they asked us to get together and kind of lay out one of the big elements that Virginia is going to talk about is prefabrication. So we looked at how many components of this building could we fabricate off-site. There's several values for that. It's one, it's a huge safety advantage to not have as many workers on site. Quality control greatly increases in a prefabrication process, and then ultimately time of install. But what you're seeing on the screen here is where we actually got together and kind of looked at a flow of design all the way through operate. And we looked at what needed to be, when you're talking about prefabrication, if you see some of the items in green, we have to pull that information back into the design and have to work through much more detail level early in the design so that the construction process is very smooth. So this is just kind of a life cycle workflow of how we're going to integrate with not only designers, but also with our trade partners, and when we needed to bring very key people on board to help us with this process.
So one of the items that we chose to prefab was the above ceiling systems in the corridors on the patient floors. And so what you see here is just a model shot of those corridors, and then also the installed racks that we built. And so this was something that it's pivotal in the industry right now of pushing towards prefabbing and being able to reduce our safety risk on a job site. It allows us to turn over projects faster to the owner because we don't have to come onto the job site as soon, so we can start prepping a lot of this stuff in advance off site. And then it can save us costs too, because it allows us some efficiencies by being able to build things on the ground and not above our heads, to where speed can speed up. And then we can get in a kind of more factory and streamlined process in the warehouses, to where the workers can really just go down the line and keep installing things without having to slow down, climbing up and down ladders again. And then working around a construction site where you may have things kind of on the floor, and it could be more of a hazard for you to kind of be walking around, that kind of stuff. So when we started the process, the first thing that we needed to do was really get everybody together. So we had what we call a big room, and it was about 40 people, and they ranged all the way from the designers, the architects, the engineers involved, to include the owners that were involved in the project side, to our team at Rogers, and then also all the subcontractors and the trades. They all had a seat in that room, and we really dove into what all the systems that were going to be required on the floor were going to be, and then really getting a count on sizes and quantities of all that stuff, so that we could then start rearranging everything and figure out where the stratifications would need to happen to try and make everything fit as cleanly and I guess in the space that we needed. And so we ended up settling on the drawing that you see on the page. It took us about 7 different iterations before we finally got to this final arrangement. And so we then issued this sheet so that everybody had it for reference to be able to see. And so the rack itself is just shy of 12 feet wide. It's about 11 foot 10, and then it's 32 feet long. And so that was something that we spent a lot of time being very careful about paying attention to, because our patient rooms themselves actually repeated every 16 feet. And so when we were trying to determine what the lengths of these racks were going to be, we wanted to ensure that it was at a 16-foot multiple of some manner, because we wanted to make sure that when we built these racks in the field, as the workers were putting the different systems on the racks, they never had to go back and reference a drawing to figure out what the dimension was that they needed to pull off of a certain point, because it's the exact same in every single rack all the way down the corridor. And so moving into kind of how this actually ended up happening in the warehouse and in the field, you see a picture of the completed rack here, and then we'll start you from the beginning. We started building out the frames. And so there's a single frame on the picture on the left, and then on the right, we actually strung all those frames for each corridor together. So we had 6 different corridors. So we had 6 different strings of racks. And then once we did that, they came in and installed their systems from one end to the other. So on the left, we've got the ductwork and the piping starting, or sorry, not the ductwork, VAVs, the pieces of equipment to be associated with it. And that was all stuff that was either supposed to be located on the lower level of the rack or the middle level. And so part of that was, as we built up, we wanted to make sure that we didn't lock ourselves out of being able to access something lower on the rack and make our install process more complicated. And so as we move through the progression, you finally kind of get to the right where you start to see the ductwork on that top row in the middle starting to be installed, while we still have some stuff left over on the outside edges to go in. And so again, this is just another one. The top left, the conduit has started to come in, and now some of the outside ductwork has come in on the edges. And in the middle, you've got both sides of the ductwork on the top coming in. All the middle tier of systems is installed and fully insulated. And then the last one, we came back and insulated the ductwork on the top itself to finish it up. And so then here you kind of see this is a completed rack, and then you kind of see a big kind of GoPro picture there that just kind of shows the mass of the warehouse itself and all those racks kind of stacked in the different bays. So then once we did that, we boat wrapped all of them. So that's what we got, the blue plastic on it. They, used heat guns and stuff to shrink it all up. And that ensured that we could make sure that it stayed weather tight throughout the travel, transport, and then also while it was still in the building, but before we've dried the entire building in. And so we're picking it with the crane off of the truck at the job site, and then we fly it up onto the 3rd floor and bring it in. And then they also came in on the 4th and the 5th floors. And then once we did that, they're on casters. We rolled them to where they needed to sit. And then we used rigging. You can see kind of a blown up image of the rigging on the right. And we, on each corner, we pulled it up, and they all coordinated how fast they were pulling to make sure we stayed level. And then we got it mounted to the deck. And so once that was up, it's structurally stable and attached to the structure, considered part of the structure. It's not like a typical trapeze hanger where it might be able to move. It is very rigid up there. And so then we come through and we start connecting the racks, rack to rack. And so that is the exact opposite of how we did it in the warehouse, because now we're not sitting on the floor, we're up against the steel. So we piece in the 1-foot pieces of ductwork that we'd left out between each of the racks. And then we move on to starting to piece in all the 2-foot pieces for all the piping and all the conduit that was there in that middle row before we can really finalize all those connections. And then once it's done, we can connect it to the rest of the building. So this last picture shows where all the conduit itself has now been connected to the electrical room where it originates from the start of the racks. So it's been a very interesting process and challenging, and everybody's super excited to see it come to fruition.
Okay, guys. So I think a big key just to mention here is that all of this has been going through communication. They started talking about those racks very early. I actually came in kind of more in the middle, so I was able to see that process on the back end and how smoothly it was able to work, especially talking with guys that have been working in that space. They really, really appreciated that. I think a big question now is that was more on, hey, these are new spaces. We're going to talk about more of these renovation spaces or spaces that have existing locations. So what you're seeing right now is 2 pictures of a machine that we use. It's essentially goes in these rooms and it's going to scan this geometry, is going to figure these things out. This machine made both of these pictures. The one on the left is solely just a picture. It said, hey, this is what's here. The one on the right is actually more so representing those points, and you can kind of see more of how there's depth to that image. So you can go to the next slide, Brian. So as you can see on the right hand side, there's a lady. She's working with that scanner. It's not big at all, but it's a very powerful tool. Essentially, that room they went in and let that thing run for anywhere from like 5 to 20 minutes. We're able to control how much detail it grabs, and from that you can kind of see just from this image, right, those tripods and how big this room actually is. This is not a picture of this room. This is once again being grabbed from that scan. This is actually more so after we've placed and pulled together scans, and this is going to be this whole area. This is actually a very, very powerful piece, I think, to our communication, because now what we're able to do is we're able to take this scan, place it in our model, and take section views of it and start being able to place and model these actual existing locations so that we can come back and communicate those to our trade partners, because a lot of times we're not actually the people installing these, but we need to make sure this information gets to them so they can obviously expedite their process and move and work as smoothly as possible. So this is, I'm not sure if you guys are familiar with Revit, but that was just a picture of a section view, just showing kind of where those are. This is more of a 3D view of that scan. And if you go ahead and go to the next one, you'll see how we're able to take that scan and grab these existing locations, model them in, place colors to them so we know what's going on, and communicate that back. This is so this is essentially a 4 flatness scan. Beautiful colors, right? But essentially what it's telling us is how flat is this floor. There's essentially a middle line. The pink is getting more into a lower space where the red is higher. And essentially what we're able to do is this is going to help us in the future with cost. So obviously if there's a floor that's very wonky, we're probably going to have to come in and talk about how we're able to renovate that later.
Yeah, this is a huge in terms of estimating cost for high-end finishes when you're looking at terrazzo and glass walls, to make sure a lot of these older buildings we get into, how you can see the structure changes from one side of the building to the other. Another really simple piece of tool that we utilize for reality capture is a 360 camera. You've probably seen some of these. You can actually buy these. You can probably buy a cheap one for about $100. You're going to start seeing a lot more of this on your iPhone and your Samsung, but this is just a 360 camera that we took. This is a piping project we did in utilities, and I'm just holding the camera above my head, but you can zoom in and out, you can rotate. And again, if you want to communicate to the owner kind of the progress of your job site, this is much more powerful than your typical 2D camera.
So what we spend most of our time on in our department is coordination of the in-building systems, that mechanical, electrical, plumbing, and fire protection, or MEPF for short. And so we want to spend some time talking through kind of that process with you. So we have very complicated models that have all these systems put together, and that's obviously not the way that you would typically see a set of contract documents coming from the designers, because they split it out by the different trades. And so our purpose is to make sure that we can get everything coordinated and clash free to help us minimize any rework and save us time in the field during the install process. But in order to do that, we use the model to coordinate it. Walter's going to talk a little bit more about how we do that process. And then in the end, we're going to create drawings that are more simplified, easy for the field to be able to use, access with dimensions and any labels necessary to identify the different systems that we need on the sheet. And then that way they can use it. And so you can see here the image that we have in the middle is actually a sheet that identifies slab penetrations. And so the image, the picture photo that we have on the right actually is representative of that drawing that we've created. You can see all the green sleeves that are placed there. And so we can identify those locations for them in advance. They can go ahead and place them and then pour the concrete after that. And that allows them to be able to not have to spend the time coring all of these holes after the fact.
So this is Navisworks. Navisworks is a very powerful software that we use. It actually works hand in hand with something I'm going to talk about here in a second called Glue, and as well as Revit. So we're actually able to push those models to the cloud. And what this is able to do is what we're looking at right now is a very, very, I would say, high level, a lot of detail. Essentially, we know where things are going and why they're going. In terms of more, even we're describing this picture, what you see is a lot of grayed out parts. And essentially, it's just saying, hey, you necessarily don't need to worry about those at this moment because we're highlighting a clash for you. And that clash is represented by those red pipes and those green lines that are going across. So if we were actually to dive in there a little bit more, we'd see where they kind of hit. And Navisworks is able to scan this entire model, essentially go through and tell us all these places where clashes are, so that this is obviously something that, hey, if they're able to go out into the field, they were going to run into these issues. The fact that we're able to make it virtually first and catch them before it actually happens, we save a lot of headache, heartache, money, time in the future. So
we wanted to show you kind of a live what this is doing when we put a building together. So this is inside of Navisworks, and what you're seeing here is the site. So these are a lot of underground utilities, a lot of things that we would get into the ground first. And as we build this model out, you can see all the different parts and pieces that go into creating this building. So if I turn on my structure, now I've got our trade partners who maybe are fabricating steel, what their information is. I could then go in here and turn on things like what Virginia was talking about. So now you can see all the duct work and all the systems that are going into that space. I can also come back in here and turn on the actual metal stud framing. So now here's all the studs and all the wall construction that'll built out. But again, this allows us layer upon layer to build that building virtually before we actually get on the site and work through as many problems as we possibly can.
So this is glue. I was just mentioning glue, and glue is a very, very just like Navis. It's not going to identify clashes, but what we're able to do is it's a very strong communication tool. All of our trade partners are able to tap into this. It's something that we can push so that literally as they go out into the field, they can literally go out here and say, hey, we've identified this. They're able to go and say, hey, this is exactly where this is. This is what this is supposed to look like. And it's just super powerful because they can be out there with an iPad, be looking at a space, look at the iPad, and it look exactly the same. And they say, okay, cool. I see exactly where this issue is. This is a really cool rendition of our theater that we recently coordinated and developed. What I do want to mention real quick is you probably see a lot of colors, and it's like, when I go to a site, when I do anything, these colors aren't something that are actually out there, right? The reason we place colors is for communication purposes. If I want to be able to hop in this model, I want to be able to see this and say, hey, that's green conduit up there. That's probably where it should be. Or, hey, this is an exhaust duct right here. Who do I need to talk to about this? Who's responsible for that? You can also see a lot of different trades in there, just like the fire protection. But this is a very, essentially Navis still, but we're able to dive in and really see what's going on in here. So coordination drawings. So obviously what we produce, so from those, I guess you could say Navis is very high level, and we're gonna kind of dive down so that when we give something to our trade partners who are out there actually working and are gonna be putting these in the field, we're gonna produce a document. It's gonna be a 2D document. And essentially, when we look at this document, it's going to give us a lot of different details. A lot of trades are actually here, right? But we're able to filter those out because the person who needs this is going in there and they're going to install the vent line, the oxygen line. So we're able to go in there, we're able to say, hey, this is exactly the size of this pipe. This is the pipe that's here. This is how high it is in that space. And this is exactly where it is in correspondence with the grid line. We're also able to take it a step further and add a lot of annotation and notes. So let's say, for instance, I was on a project and there was a space that we weren't able to fully coordinate yet due to some information we didn't have. We're able to cloud that, say, hey, this is here, don't really look at this. This is still waiting further coordination. Or it could even be something more specific as, hey, this is where, this clean out or this riser penetrates this roof. And we're able to place that on the drawing as well.
So we've spent a lot of time talking about the inside of the building so far, but one of the things we also coordinate is the outside. And that is because the civil contractors that we have don't always come onto the project team as early as when we may want to go ahead and start the coordination process. And so our department often will model all the existing site based off of the surveys we receive, and then start modeling in and coordinating to check for any conflicts that we may have with the proposed design. And so we have a number of different campuses where we actually have repeat projects that we keep going back. And as we do that, we have started to build full campus models for a lot of these places. And so what you see here is the local Charlotte Community College and some of the campus site work that we've actually built out for this one, because we've touched so many buildings at this point. We've been able to piece together all of this underground, and it's really served a great function for the college itself, not just us, because they now have something that's documented and actually modeled in 3D. And so they really enjoy that. But we do generate drawings, site work drawings off of this. And just like inside the building, we tag and we dimension everything. It's a little bit different dimensioning wise when we do the site work, because we're not referencing them back to grid lines like we do inside the building. So in that situation, we will identify actual coordinates for the site work contractor once they're ready to install, to be able to go out there with a robot and GPS locate each of these spots so that they can shoot a point, know exactly where to dig and place these different utilities. And so this is just a kind of a blow up example of it. You can see all those different elevations, all those different coordinates that we've identified to help guide them in the install process.
Yeah, if you're going to have a problem on a job site, it's usually coming out of the ground. And when if you have asked somebody to go locate utilities, it's usually easy to find the X and the Y. If you think about coordinates, but it's very difficult to figure out the depth. So this is where we're taking the time to figure out all the depths and heights, which is extremely valuable, not only for us in construction, but also valuable to the owner and the client for future development. So. Mm-hmm. We also spend a lot of time even on high-end stuff. So we've kind of showed you kind of a lot of the behind the scenes type stuff in the building. This was a restaurant bar type space for a senior living facility. And the owner was very particular about what they wanted this space to look like, how it's supposed to be. He kind of had a vision in his head. So we took the time to detail out all the studs and all the high-end finishes. So wood trim, we actually did all the corbelling on the granite. And through this process, we learned a lot of stuff. We learned that we had some issues with how to install this glass on this column. We had some connection details with how to do this little flip up bar as for the staff that has to walk in there. They had some issues with the install and the lights. So again, we spent a lot of time detailing out these finite details, but they solved a lot of issues and helped us solve a lot of problems early in the process. And then ultimately, if we do a great job, this is kind of what we want to see. We want to see the early communication on the left and the working with all of our people and all of the designers and trade partners, ultimately to get to where you're on the right, which is a very complicated install of a building. So we're going to switch gears a little bit here and talk about kind of visualization now. How do we use some of the newer technology that you see this day and age for communication, augmented reality and virtual reality? So if you had to guess, you can take a guess. Does anyone want to guess at which one's a picture and which one's actually a model? And we can answer that in a few minutes. But this is a virtual mock-up. You can kind of see some of the software we used to put this together. But this was, when I click on this was a cancer center. And we had 130 plus of these exam rooms. So they're very repetitive. So we wanted to make sure that we were going to get every detail right. So we actually built this out virtually. We worked with the architect, the interior designer. We got colors. We got, furniture placement. We put in light switches. So what you're seeing here is not a photograph. This is actually a virtual mock-up. We even put the labels on the glove boxes. So again, in such a repetitive environment, we wanted to make sure that all these, and again, we had nurses looking here, we had doctors, and this is a great way for them to change things on a drawing before somebody comes out on the job site and realizes, no, that's an issue, and now I've got to change it 130 times. So we did a virtual mock-up first, and then we actually had the value of doing a physical mock-up. So now this is the reality. So we built out that exact space. You can kind of see that the bed that we had in there was a little bit different. You can see they're missing the glove boxes. They actually put a little bit more equipment in here that we had. But again, it's really awesome to be able to compare this kind of true mock-up to what we spent time working on in the virtual environment to make sure that we got things right. This next one was even a little bit different of a story. This was a gas utility company. So this was a new facility where they were going to teach their technicians on how to install gas equipment. So gas furnaces, gas water heaters. This was where they were going to train people. Now, they had an architect work with them and they kind of understood the space, but they really weren't sure how they were going to use this room and how they wanted to lay out. So we worked very early, this is like a schematic level with the architect to actually build this out to a very high level of detail. We probably then met with the owner about 4 times and we had their technicians and some of their senior staff come in here and they said, hey, we need more outlets. We need to change the location of where this piping is going to be. I think this gives us enough space to put 6 appliances. We want to change the casework around. This was a tremendous tool in them getting what they wanted in the end. I do not think that this client understood. They had an idea, but they weren't designers. So they really wanted to see what they were going to get before we actually constructed it. And they were extremely pleased with how this project turned out. And I think this virtual reality was a huge part of that. So now we want to focus on one more kind of project profile for y'all to see. This is the Charlotte Douglas International Airport, and we did a huge expansion. This is called Terminal A for the airport. So again, I talked a little bit about the beginning about how of a kind of a big small contractor we are. Now you'll notice here we actually did this is what we call a joint venture. We teamed up with a much larger contractor to do this project. So why did we do that? One, the airport is owned by the city of Charlotte. We are headquartered in Charlotte. We've been doing business in Charlotte for over 50 years. We have a great relationship with the city of Charlotte because we do a lot of work for them. However, we didn't have a lot of experience with airports. Turner Construction, which some of y'all may know, has a great reputation for airports and airport construction. So when we chased this project, we decided this would be a great team. So we had the expertise of a larger contractor that does a lot of airports and the local expertise of our company. And again, so this project we built together as what we call Turner Rogers, which was a joint venture. So a little bit about this project. This was what you're seeing kind of on the top left is the existing airport. This was a new 230,000 square foot addition, really, really long corridor based on kind of the layout of the site. It had 10 new gates for planes, $115 million, 21-month construction. This was the first time that the airport had upgraded new gates in 16 years. So this was a big project for them. And important here, we had about 34 different trade partners. So, we talk a lot about the architect, the owner, and the contractor, but we had an army of people that we work together that we have to communicate information across to make this project happen. So I'd say at some point in time, we probably had over 600 people on site working on this project. It was a very interesting design. The structure had these huge curved trusses. These columns were designed by the structural engineer and they were actually had to be cast. They couldn't be kind of drawn out like a typical steel beam. They were actually cast in a factory somewhere to make this really interesting column connection. But again, that was just kind of one of the unique features. But early in the process, they came to us and they said, this is a long building. We're not quite sure how people are going to move through this. We really want to see what it's going to look like, what the feel is going to be, how the flooring is going to look, how the lighting is going to work. So they asked us to create a video. So again, we sat down for a while. This one probably took about 6 weeks. And we built out this video of how you move through the space. We took the time to put the terrazzo floor patterns in. You can see the signage that they wanted to see. They asked us to put in where the airplane, monitors were going to be for the departures and the arrivals. So again, this was working with the design team as well as the owner to we changed this several times. We changed the lighting. based on this rendering in this video. But this was a tremendous tool, and I'll run the video one more time so you can see it. But again, it's just a huge tool. They ended up using this as we started construction. This is actually about a minute of the video, but they actually took the full video, which was about 5 minutes, and put it in the lobby of the airport when we started construction, because they wanted people to see what we were building and what they were getting involved with all the construction debris around their project. So really interesting. It's a lot of fun when we get to do stuff like this. Walter mentioned kind of passion for video games. This is kind of a lot of that, you know, video game technology that we put into the design of a building. And then here's some kind of, you know, final shots of that building. It's a really awesome building that comes up. It's the first thing you see when you drive into the airport. If you ever fly, Charlotte is, I think, number 5 or 6 busiest airport in the country. So if you're flying internationally, you may actually go through Charlotte, and if you get a chance, stop in and see the terminal. This is what you see as you drive up, and then this is the view looking right out that glass. So kind of the last thing I want to talk about here is augmented reality. Now, augmented reality is kind of playing with virtual reality. It's actually taking a virtual environment and then actually putting it over a real environment. So you can kind of see a picture of me. I'm wearing HoloLens. You've probably heard of this. It's actually made by Microsoft. But what you can see the picture of me. It's just a dirt site. But what you're seeing in the video is all the underground utilities that I see through the glasses of what's going to be out there. This is an awesome tool. It's still new technology. You're starting to see a lot of commercials with things like, you know, Apple and stuff, where you can actually put a couch in your room and things like that. But again, this is a new technology that we're constantly looking at for new ways to use on a job site. We think it's going to be a huge thing for safety. But can you imagine, you know, somebody has to dig, you know, a water line or something, and making sure that he doesn't hit other existing utilities. But it's expensive technology, but it does provide a tremendous value from a communication standpoint. So we're continuing to look at this, trying to find new ways to use it. And you're going to see this more and more as construction continues to grow and technology continues to change.